Hi, my name is Emmanuel Sechet, and I will present WiFiMon, a joint work with my colleagues at UMass Amherst and Smith College. WiFiMon uses Wi-Fi sensing that captures when users connect and disconnect from Wi-Fi access point. When a user enters a building and connects to an access point, that access point will put an entry in its syslog file saying this user with this MAC address connected to this access point. When the user moves within the building and connects to another access point, the new access point will also put an entry saying this MAC address has roamed and is now here. The previous access point will log an entry in its syslog file saying that the MAC address has been disassociated and moved to another access point. We aggregate the syslog files from every access point, and we rebuild the list of MAC addresses and users and at what time they visited each access point. To monitor building occupancy, WiFiMon needs a location of access points on each floor of each building. So in this file here, we know that those 3 access points are on the first floor of the computer science building. Additionally, we can provide information about the maximum capacity of this floor. For example, here 95% can be on the first floor of the computer science building in normal times. And during COVID time restrictions, we can also specify the capacity, for example, here 25% maximum. User can also provide occupancy per access point, which represent the capacity of the area covered by the Wi-Fi access point. For example, in this case, 50 people maximum in the area covered by this access point in normal times and only 14 in COVID times. We use Elastic Stack to process, store, and visualize the data. Logstash is a component that parses the syslog files and aggregates the occupancy data to store the results into Elasticsearch, which is a JSON database. WiFiMon also supports encrypted usernames and MAC addresses for additional privacy. Kibana is a tool that creates Elasticsearch and displays the results into dashboards. It's very useful for building occupancy monitoring, as it allows the user to quickly pinpoint hotspots in buildings, floors, or around access points. When a user tests positive for COVID, the contact tracer needs to be the list of other users who are in contact with that person. First, we retrieve the list of MAC addresses that belong to the user, whether it's a phone, tablet, or laptop. Then for each of those MAC addresses, we retrieve the list of APs they connected to. For each access point, we retrieve the users that visited those same access points, and we compute the times they spent at those access points and see which ones overlap with the users that tested positive. It can happen that users that are close to each other are actually connected to different access points. So to address this issue, we also retrieve the list of all users that were on the same floor and building at the same time as the users that tested positive, and we build a list of possible contacts as well. The contact reports can be visualized in our contact tracing dashboard, where the contact tracer can select a user and a time slice and visualize the results. And in one click, just exports the list of potential contacts with the time at which those contacts happened. WiFiMon is open source software. Feel free to download it along with the documentation on GitHub. Thank you for your attention.